Assalamualaikum and hi, my name is ASRUL HAYAT bin Abdul Razak. My metric number is B09181029A and my supervisor is Dr. Mastura binti Muhammad Taha. Today I'm going to present about my bachelor degree project 1 entitled Development Chemically Treated Sugar Palm Fiber Reinforced PLA Composite for Fused Deposition Modeling in 3D Printer. Okay, so now we will start with an introduction for my research. 3D printers is an advanced technology that used to print a 3D dimensional shape or object into real life. 3D printers was introduced in the market in around 1990s. 3D printers has variety use of technologies. One of the most used technologies in 3D printers is fused filament fabrication (FFF), or as known as fused deposition modeling (FDM). 3D printers need an ink or filler to make a printing process, but instead of use liquid ink as the normal printers, 3D printer use a solid filament to do a printing process. So how the printing process on 3D printers went? 3D printers use a extrusion process concept to do the printing process. The filament will go through the nozzle that have heat mechanism, and it will melt the filament, and the nozzle will deposit the melt state filament in layer by layer to create the object desired. Okay, in this research, we want to compare whether biocomposite material or 100% PLA material is good for creating filament for 3D printers. So, what is meant by biocomposite? To understand biocomposite, we have to take a look on the definition of composite. Composite material is a combination of two materials, such as ceramic combined with silicon and glass combined with steel. So, back to biocomposite. It brings the same definition, but instead of normal material, one of the material in the composite is from natural fiber, like knaf, coconut fiber, leaf, and more. It was proved that composite material have higher in strength and have lighter weight compared to normal material, and it also can reduce the usage of plastic in filament. In this research, there is a few analyses need to be done to see the thermal properties and rheological behavior of the new material to see whether biocomposite material is better than PLA or vice versa. The analysis also used to find the specification for the new material so that it can suit the 3D printer nozzle. There are three analyses and studies that involve in this research. First is thermogravimetric analysis. Second is differential scanning calorimetry, and lastly is rheological studies. All of this analysis is used to find the thermal properties and behavior of film of the new material. So now we proceed with problem statement. Problem statement is the reason why this research is being made. So first problem statement is recycle issue. So is the filament that use PLA cannot be recycled? The short answer is yes, it can be recycled, but due to its melting point, it is not the main consideration to do recycle on PLA. Okay, second problem statement is thermal deflection and strength. Commonly, thermoplastic filament like PLA has low thermal deflection. So due to these circumstances, which make the melting point of the PLA is low, the usage of 3D printers that use 100% PLA only for prototype and modeling phase. Next problem statement is thermal properties and rheological study. Okay, thermal properties need to be obtained the data because we want to see that whether the biocomposite thermal properties is suitable with the nozzle temperature, so that the problem like filament stuck in the nozzle can be avoided. The last problem statement is plastic reduction. As we know, PLA is also one of polymers which is also a plastic. So by merging sugar palm fiber together with PLA in creation of filament, the reduction of plastic can be happen. For example is, if we compare before, instead of 100% PLA, when we merging for example like 30% of sugar palm fiber into the creation of filament, there is a reduction of plastic usage in amount of 30%. Okay, for this research, there is a main objective, which is firstly is to develop sugar palm fiber reinforced PLA through extrusion mixed with different fiber loading. And second is to characterize thermal and rheological properties of the composite. So first objective is for the first phase of the research. First phase research have a few process, which is degradation of the sugar palm fiber. Second is fiber treatment. Third is different fiber loading into the internal mixer, which is 2.5%, 5% weight, and 7.5% weight. And lastly is extrusion process to deposit the filament of the new biocomposite material. Okay, second objective is for second phase of the research, where analysis of thermal properties and rheological behavior has been made. It is want to see whether the biocomposite material show an improvement or degradation of the properties to compare with the 100% PLA properties. Now we move on to the research scope. There is a few scopes that attach to the research. First thing is the material of natural fiber that we use is sugar palm and PLA polylactic acid as the metric. Next is the duration of SPF into the 125 micron and the different fiber loading during the internal mixing process, which is 2.5 weight, 5% weight, and 7.5% weight of sugar palm fiber. Next, in the extrusion process, we use twin screw extruder. It has the excellent mixing effect for natural fiber, which can evenly distribute and weighted in the PLA. And the last thing is analysis that we use is TGA, DSC, and rheological studies. For literature review part, there is only selected literatures that I would like to present in this presentation. So first thing is low density biodegradable sugar palm fiber materials that can be used with polymers materials to produce partially biodegradable composite material. Next is the fiber loading of sugar palm fiber was found to increase the thermal stability of biocomposite. Next, the sugar palm fiber that has been bleached, acetic acid, and sodium chloride, and alkali treated sugar palm fiber will possess an advantage such as a better thermal stability. The density of sugar palm fiber starch PLA bilayer films can decrease as the proportion of PLA was reduced. Next, second last is when fiber content increase, the tensile modulus shows significant improvement in sugar palm fiber reinforced HIPS compound. The lastly is adding weight of synthetic cellulose fiber to PLA. The tensile strength can be increased 1.45 times and the tensile modulus can be increased in 1.70 times. Okay, based on all of these literatures that have been selected, we can conclude that natural fiber really give good impact in creating composites such as increasing thermostability, increasing tensile modulus, and thermal deflection. Thermal deflection can be raised. So now we will move on to the methodology for this research. Okay, in this part of methodology, I will explain about the method and process used in this research during lab session. First is degradation of sugar palm fiber. Okay, sugar palm fiber was received in a long and continuous form. So from that kind of form, you need to degrade the size until 125 micron. To do that, the process of cutting and sieving and crushing is need to be done. The first step is the sugar palm fiber need to be cleaned with tap water to remove foreign matter. Then it has to be dried to the room temperature. The next step is we have to cut into 1 to 5 mm to avoid stuck in the crush machine. Next step is we have to smaller the size, degrade the size using crusher. Because of the limitation of the machine, it's not all of the sugar palm fiber that insert in the crush machine have degrade into the 125 micron. There is still a big size of sugar palm fiber. To separate between the 125 micron of sugar palm and bigger size, sieve process have to be done. Sieve process use a sieve machine that have a layer of 125 micron, which it used to separate the bigger size of sugar palm fiber. After the desired size of sugar palm fiber have been obtained, which is 124 micron, the next method is we have to make a fiber treatment for the sugar palm fiber. There is two components that really important in this sugar palm in this fiber treatment, which is which is sodium hydroxide and silane. For the first treatment is using mixture of now solution. The step is we have to prepare now solution with 6% of it combined with H2O with water 94%. Then SPF powder have to be soaked in it for 2 hours, and we have to make sure that it was immersed in it completely. After 2 hours, the SPF have to be rinsed with tap water before it dry in the oven at 104 degrees Celsius for 24 hours. For the next treatment, the mixture is the combination of silane 2% and 90% of methanol and 10% of water H2O. Next, after the mixture is complete, we need to set the pH of the mixture to 3.5 with acetic acid and continuously stir it for 10 minutes. The same SPF that used in the now treatment is also immersed in the mixture for 3 hours. Then it will rinse with distilled water and it will dry in the oven for 60 degrees Celsius for 72 hours. Next is extrusion process. Extrude machine that used in extrusion process is twin screw extruder. This process used to deposit this three new type of filament. After the three different fiber loading of filament has been deposited, next it will be the characterized properties method. In characterizing properties method, there is a seed specimen will be used, which is 100% PLA, treated sugar palm fiber, untreated sugar palm fiber, and three filament with different fiber loading. There is three different analyses that have been stated before. For thermogravimetric analysis, used to check the obtain data of thermostability, while different scanning calorimetry used to see data like crystallization, glass transition, and melting point. While rheological study is to see how the material flow or deform under an applied force during a melt phase. For expected result, it is expected that in TGA finding, thermal stability of biocomposite material will be higher than 100% PLA, and also the degradation of temperature also will be higher. And for DSC finding, the expected result is glass transition temperature, melting point, and specific heat capacity also will be higher. In rheological study, it is expected that determination of correct processing behavior will be found so that it can suit the nozzle of the 3D printers. For conclusion, it is expected that the usage of plastic really can be reduced. Creation of strong filament and stiff can be produced. New knowledge can be gained from this research about sugar palm fiber that can be implemented into a bigger field like construction material.